The world's first photograph was taken in 1826, and it was a groundbreaking technology to capture the 3D world into a 2D picture. But it seems like it wasn't enough to challenge the technological powers, as we are now working on turning a collection of still images into a 3D model. And with the help of NVIDIA Instant Neural Graphics, we can get our 3D model in just a few seconds. So in this video, we will discuss NVIDIA Instant Neural Graphics. Make sure to watch the video till the end, as we will discuss how it overshadowed other neural network models. NVIDIA Neural Graphics have gained so much attention and popularity in recent years, it seems like artificial intelligence has found its way into computer graphics, as well as we can see that NRC combines the AI and ray tracing hardware to build RTX graphic cards. And now NVIDIA introduced Instant NGP, a framework that allows a neural network to learn the representation of gigapixel images, 3D objects, and NeRFs in seconds. The researchers of NVIDIA relied on a combination of the hash table of voxel and neutral network to allow high quality with faster training. Isn't it amazing? The main aim of introducing this card is to pave the way for the global extension of AI technology for computer graphics. NVIDIA researchers said, "We have demonstrated that single GPU training times measured in seconds are within reach for many graphic applications, allowing neural approaches to be applied where previously they may have been discounted." Researchers from NVIDIA have developed a method to use neural graphics primitives using a single GPU in just a matter of seconds. Four main components of this method are: Number 1. Signed distance function. The neural signed distance field is the feature of the Instant Neural Graphic. It is emerging as an effective representation of 3D shapes. SDFs encode 3D surfaces with a function of position that returns the closest distance to a surface. It is a valuable technique in 3D construction and rendering. In simple words, it is a mapping from 3D coordinates in a virtual world to distance to a surface. It learns the geometry of objects better because it knows what parts are inside and out. Number 2. Neural radiance caching. Neural radiance caching learns a denoise radiance and density field directly from a volumetric path tracer. It is a method for path-traced global illumination. It is designed to handle dynamic scenes. It is a light transport simulation. It handles fine-scale textures such as albedo, roughness, or bump maps, and scales to a large outdoor environment. Number 3. Neural radiance field. Scientists use artificial intelligence to approximate how light behaves in the real world. It enables the researchers to construct a 3D model and 2D images taken at different angles. This process is known as inverse rendering. A new technology known as neural radiance fields, or NeRF, uses neural networks to represent realistic 3D scenes based on the collection of 2D images. It trains a small neural network to fill in the blanks by efficiency predicting the color of light radiating. It simply takes a set of input images of a scene, and output is a volume whose density and light depend on the direction of view and light emitted. Yes, we all have seen this in science fiction movies, but it is actually happening in reality. Well, the results shown by the neural radiance field aren't what they are now. This learning-based method has evolved so much. The early version of NeRF was developed to evaluate the effectiveness of various light-based devices, but now we are using the same method to convert 2D pictures into 3D models. Early NeRF models have produced quality renderings, but we have to wait from hours to days to train. Training a NeRF required more than 12 hours just a year ago. NVIDIA researchers worked on this problem and developed Instant NeRF. The time has been reduced to 5 seconds to train a scene and deliver real-time rendering. It is the fastest NeRF technique and can achieve more than 1,000 times speedups. Instant NeRF could be as important to 3D as digital cameras and JPEG compression have been to 2D photography, vastly increasing the speed, ease, and reach of 3D capture and sharing, David Lupka, VP for Graphics Research at NVIDIA, said in a statement. Number 4. Neutral gigapixel image. It is a digital image bitmap with tons of data in it and AI that creates a neural representation of this image. The size of the gigapixel is reduced while retaining semantic information. AI increases its highly compact representation and shrinks the particular dimension of an image. So as you zoom in on the image, you will find some great details about it. NVIDIA came up with a new input coding method called multi-resolution hash grid encoding to give instant results. It's optimized to run efficiently on NVIDIA GPUs. There are massive performance gains realized with the new input coding method. It has been shown that a NeRF, or neural radiance field, can be trained in just 5 seconds. This can be performed on a single high-end GPU that anyone can purchase, rather than an expensive network of super powerful computers. The graphic primitives are represented by mathematical functions that parameterize appearance. The ultimate goal of the team is to have detailed and high-quality graphics. So the finer a grid of data, the more costly it is. Functions represented by multi-layer perceptrons are used as neural graphic primitives. The potential concern with MLP is that it requires structural amendments such as merging, splitting, or pruning. It can make the training process more time intensive, and these issues have been solved by the team by its multi-resolution hash coding. We can see that the encoding and its implementation provide high-quality, rapid training, and simplicity benefits. Encoding is task agnostic, which means that it uses the same implementation and parameters across all tasks. Multi-resolution hash grid encoding has enabled NVIDIA to reduce the cost of neural graphics. Other neural graphic primitives can be very costly as they are parameterized by fully connected neural networks. NVIDIA has reduced the price by introducing new input coding that permits the use of the smaller networks without sacrificing the quality. It reduces the number of floating point and memory access operations. A small neural network is extended by a multi-resolution hash table of trainable feature vectors whose values are made effectively through variational gradient descent. This structure allows the network to define hash collisions. The whole system is fully fused with CUDA kernels, which can minimize the wasted bandwidth and computer operations. It causes a speed up of several orders of magnitude and renders in tens of milliseconds at a resolution of 1920-1080. Hash tables are allowed for fast operations regardless of the size of data. The process can run very fast and smoothly if you know the index value. When performing training operations, no structural updates to the data structures are required. This is the best thing about hash tables according to us. The hash tables will automatically prioritize the meager areas with essential fine scale detail. This is important because you don't have to spend time and computational resources on empty spaces or spaces with less detail. For example, an area of an image with coarser detail will not be queried repeatedly across unnecessary fine resolution, resulting in more efficient and faster training and rendering. It's also important to encode an input at multiple resolutions because doing so ensures that a neural network is trained faster and more efficiently in areas of 2D or 3D graphic that includes high level of detail. The appropriate level of detail is learned and you achieve high-quality results. As we can see, the progress in the field of artificial intelligence and information technology is definitely excellent, and it is getting incredibly better with time. Usually, technological advancements focus on either speed or quality, but NVIDIA can achieve both simultaneously. We all wanted such technological advancements, and now it's finally happening. As we all know, the metaverse is taking shape right now, and it seems like NVIDIA has gone all into it. It could be used to create avatars or scenes for virtual worlds, capture video conference participants and their environments in 3D, or reconstruct scenes for 3D digital maps. The application for the Instant Neural Graphics can be many, from quickly scanning natural environments or persons, so that the game creators can then use the digital scans in their projects for training self-driving cars or robots to understand the shape and size of real objects. So this was our video on NVIDIA Instant Neural Graphics. What do you guys think about the features of NVIDIA Neural Graphics? Which component among the four is your favorite one? How will it be able to play an important role in the metaverse? Tell us in the comment section below. We love to read your comments.